This is the introduction to section 6-7. This is part 2. And in part 1, again, we looked at figuring out what shape do we have from a coordinate plane, using slope, distance, all those types of things. And we're going to continue with that here. These are just more examples. So it says here, parallelogram MNPQ has vertices of those four ordered pairs. Is this a rectangle? Well, let's take a look here at this graph, and let's put these ordered pairs in here. We've got the ordered pairs 0, 1, which is right here. We've got the ordered pair -1 and up 4, which is right here. And that's letter, in this case, N. And then we've got right 3 up 2, which in this case is going to be Q. And then right 2 and up 5, which in this case is going to be the letter P. So there's our shape. And we have to decide, is this shape a rectangle? Now, how do we go about doing that? Well, to distinguish it between a rectangle and a rhombus, we know we can do a couple of different things here. We could say that the difference between a rectangle and a rhombus would be that the diagonals are congruent in a rectangle and they're not in a rhombus. We could also say that we got to show that there's 4 90-degree angles. So let's go ahead and let's start with that. So what I need to do is I need to show that NP is perpendicular to PQ and that PQ is perpendicular to MQ. If I can show that, I know there's right angles, so then I know then that it would be at least be a rectangle. Okay, because I know it can't be a rhombus because a rhombus doesn't have right angles in it. So, NP, let's take a look. In order to find that they are perpendicular, we got to use their slopes. So, for NP, I'm going to take 5 minus 4 divided by 2 minus -1, which is going to be 1, and this becomes positive over 3. So, PQ. In order for it to be perpendicular, remember, it has to be opposite reciprocal slopes. So, PQ, I'm going to take 5 minus 2 over 2 minus 3. 5 minus 2 is 3. 2 minus 3 is -1, so really this is -3. And then I'm going to look at MQ. MQ, the slope, 2 minus 1 over 3 minus 0, which is going to be 1/3. Okay, so now as I look at this, I see that these two right here are opposite reciprocals. So I know that PQ and MQ are perpendicular. And I also see that NP and PQ are also opposite reciprocals, so they are perpendicular. So I know for sure that this is a rectangle, at least to start, okay? Because all angles are perpendicular, or because all of these are right angles. So is that a rectangle? Now, another thing that you could do is you could see if all the sides are congruent, which is what is leading to letter B. Is this a square? Okay. So, in order to do this, to see if it's a square, I have to see I know that my angles are all right angles. Are my sides congruent? So I've got to find the distance of these values. PQ, NP, MQ, and MN. Okay, so NP, I would take the square root of -2 minus -1 squared plus 5 minus 4 squared, which is going to be essentially 3 squared plus 1 squared. 3 squared is 9, 1 squared is 1, 3 and 9 is 10. Now, PQ. I want to find the distance to PQ. Square root of 3 minus 2 squared plus 2 minus 5 squared, which is going to be 1 squared plus negative 3 squared. Negative 3 squared is 9, 1 squared is 1, 9 and 1 is 10. So I know I got two of them done. I'm halfway home. MQ. MQ. Here I take the square root. For MQ, I would go 3 minus 0 squared plus 2 minus 1 squared, which again, 3 minus 0 is 3. 2 minus 1 is 1. Again, it's going to be the square root of 10. Now, again, if you have 3 sides that are going to be the same, 99.9% of the time it's going to be the fourth. So is this a square? Again, I could find mn. Mn is going to be the square root of 10 as well. Is this a square? Yes, it is a square. Why? Because all sides are congruent and you have all right angles. Okay? All right, let's take a look at this last example now. You've done an example like this. Let's have you see if you can do this on your own, and then we will hit pause, and then we will check it. Okay, now that you've hit pause, let's take a look at, first of all, let's look at the graph here. Let's plot these points on our graph. So, DEF, triangle DEF, we've got 0, 0 to start. So there's 0, 0. That's going to be point D. E is right 1 and up 4. And F is right 5 up 2. So we got D, E, and F. There's our triangle. We have to decide, is it scalene, is it isosceles, is it equilateral? Now, in order to do that, I'm going to have to show the distances. So I need to know the distance of DE. I need to know the distance of EF. And I need to know the distance of DF. So, let's start with DE. To find the distance of DE, I'm going to take 1 minus 0 squared plus 4 minus 0 squared, which is going to be the square root of 1 squared plus 4 squared. 1 squared is 1. 4 squared is 16. 1 and 16 is 17. So I got the square root of 17. EF. I go find the distance of EF. Here, square root. In this case, the distance of EF, I go 5 minus 1 squared plus 2 minus 4 squared, which in this case is 4 squared plus negative 2 squared, which 4 squared is 16, negative 2 squared is 4, 16 and 4 is 20. So, right now, I can eliminate the fact that it's an equilateral triangle because I know all 4 sides are not going to, or all 3 sides, excuse me, are not congruent to each other. But I haven't ruled out whether it's an isosceles triangle yet. So, DF. Again, on DF here, so I'm going to go 5 minus 0 squared plus 2 minus 0 squared. This is 5 squared and 2 squared. Well, 5 squared is 25. 2 squared is 4. 25 and 4 is 29. As you look at all 3 of these sides distance-wise, none of them are the same. So therefore, this is a scalene triangle. Okay? All right, so these are 3 more examples here for section 6-7 part 2 to go through and look at. Okay? Don't forget to complete your WSQ when you're finished.